Hi guys, so this is part 2 of 1C. Again, this is what initially it looks like. I did question number 3, and now we're going to look at question number 6. So here, find the y-intercept of this relation that's written in factored form. And then they want to know if this equation in standard form is equivalent. So we want to see if they're actually the same. I can graph it and then I'll show it to you algebraically as well. To find the y-intercept, you have two options. For the y-intercept, you know that our x value would be equal to 0. So you could substitute 0 in here for x. You also know that if it's in standard form, the y-intercept should be this last value here at c, which would be the constant. So when I do my algebraic technique, I'll show you both ways, and hopefully you will get the same answer towards the end. So let's take a look here. They want me to find the y-intercept. So if I'm gonna do the notation, again, I know that I would have to write here, let x is equal to 0. And anywhere in the function that has x, I'm gonna substitute 0 instead. So y is equal to -5, 0 minus 2, and this is 0 minus 12. So I know this answer would be reduced to -2. This answer would be reduced to -12, and we're multiplying this by -5. So here I have -2 times -5. This is going to be equal to +10. And then I'm multiplying this by -12. And this one is going to be equal to -120. Okay. So if I wanted to identify the y-intercept, we would say therefore y-intercept is at an x value of 0 and then a y value of 120. Now, when I look at that question for part B, if it's actually equivalent to this expression here, I would either try to expand this expression, so maybe we'll practice that, and then see if those are the same A value, B value, and C value. We can already see that it's not because of that -120, but if we use a different technique by expanding, let's try that for this. So let's try to expand this factored form equation here and here. So I'll rewrite y is equal to -5, x minus 2, and then x minus 12. So because you're multiplying here, here, and here, it doesn't matter if you multiply this first term first or the second and the third term next, as long as you're not obviously distributing this -5 to both brackets, because then you would be multiplying it by 5 twice, which we don't want to do. So I'm going to take this first term first. Remember, when we have brackets, we say hi mom, hi dad, and then who's ever coming with you to the house, they'll also say hi mom and hi dad. So let's expand, and let's use different colors so we know what we're expanding. So this -5 is going to stay the same. So here's me and my brother. We're going to say hi to my mom and my dad. So this is me, hi mom, hi dad. So x times x would give me x squared. X times -12 is -12x. And then my brother is going to say the same thing. He says, hi mom, hi dad. So -2 times -x is -2x. And -2 times -12 is going to be +24. So in this bracket, I want to simplify the like terms first. The only like terms that I see are these two in the middle. So they both have linear terms. And if I add these two terms here, I'm going to have -5 x squared. This is going to be -14x, and then plus 24. So now that I multiplied the second and the third term, I will distribute this 5 now to every term. So everyone's going to get multiplied by 5, but also negative. So this term is going to be negative 5x squared. These two negatives will make a positive. So this should be plus 70x. And this negative 5 multiplied this positive 24, it should be equal to negative 120. Okay. So I can see, is it equivalent to our original here? The first two terms check out. It's this last term that this is positive 120 for the y-intercept, and this one would be not, negative 120. So we would say not equivalent. And we would write y-intercepts are different. You can plot it on Desmos to check our algebra and see.